Okay, I'm going to add a few things from the appendix of the book here in terms of evolution before we go to the evolution of modern human and evolution of behavior. Obviously, we are generally think of evolution as a long-term slow process, and then you have to deal with the geologic time scale, continental configuration change, and climate change as well. So the idea of the course itself is to look at the interaction between climate and modern human. But what about the general evolution over time? So if we go back to the time of the Charles Darwin's book, just before him, Erasmus Darwin, the grandfather of Charles Darwin, also was an evolutionary biologist, and then came Lamarck. Lamarck created a lot of controversy which still goes on. So let's look at the 4 laws of Lamarckism here. There is general trend for an increase in size in evolutionary lineages. This is often true but not invariable. This law prompted little discussion or criticism. Okay. Secondly, organisms respond to needs by evolving novelties of behavior, physiology, and anatomy. This is equivalent to the neo-Darwinist idea of selection pressure producing evolutionary change. The difference is that Lamarck thought the organism was striving to change. Darwinists think that biological change is random and non-universal. So this is the idea of directed evolution, where organism itself is inducing change based on its needs of survival, avoiding predation, moving to different climate, and so on and so forth. Whereas Darwin would say random mutations happen and then natural selection happens to decide who survives and who doesn't survive. Use and disuse, organs that are used more get bigger, organs that are used less get smaller. So Darwin also adopted this for his own theory, and it's not a debatable issue among modern evolutionists. There are vestigial organs that evolved but were not used, so they have become extinct but leave some vestiges. The inheritance of acquired characteristics. Darwin finally adopted this too, but his descendants rejected it. So the idea of Lamarck that was most controversial was that in a generation a species can acquire behavioral or developmental characteristics, cultural characteristics that are then genetically transferred or transmitted to the next generation. So this is still debated, but now maybe this debate merges with the so-called epigenetics, where some characteristics are transferred without going through the genetic mechanism, so they're called epigenetic. So then why don't we just ignore Lamarck and stick to Darwin? Well, Lamarck put progressively evolutionary complexification at the center of his theory, that an organism continues to seek evolution for its benefit and gets more and more complex. Darwin acknowledged that this was problematical but didn't know how to deal with it. Neo-Darwinists treat it as an accident of adaptation and natural selection. So if you look at evolution of species and complexification, they think this is an accident of adaptation and natural selection. So they have no constructive explanation of how the human condition evolved. I feel some breeze, so maybe there is some problem with the sound, but I'll check. Lamarck made the organism as an agent of evolution. Although Darwin understood that organism was important, natural selection was paramount. So random mutations and then natural selection. Then the question is how often these mutations happen. People believe that there are emergences where strong or weak emergences happen, new genetic characteristics evolve, or that there is punctuated equilibrium where sudden evolution happens and then there is stasis for some time, which means when the next sudden evolution happens, the species that have existed may make it difficult for the newly evolved species to survive, and so on. Okay, so why some of our human ancestors disappeared, for example. One of the most fundamental aspects of all evolution has been the action and interaction of individual organisms, like predators and prey. Yet neo-Darwinists ignore the organism, defining evolution as the redistribution of alleles in population-wide gene pools. Well, alleles are basically genes. When you are born, you inherit a set of genes from your mother and your father, so color of hair, your height, color of eyes, etc. And one of them gets expressed. So that's why we call them alleles. Gene is what is expressed and alleles is what you got. So you have two of those. So there is the idea of the selfish gene, which says it's the genes that are trying to propagate themselves, but the organism is no more than a temporary agglomeration of genes. In contrast, some modern biologists and philosophers take the view that the whole organism in its environment must be taken into account, as well as its interacting hierarchical components from molecules to mind. So is it the gene that is getting selected, or is it the organism as a whole with a set of genes that is getting selected? So this is an argument. So that is where the happy monster idea comes from, that suddenly a new a species is evolved, let's say, that survival of that species depends on various things like surviving the species that are already existing versus finding a species suitable to mate with and reproduce and propagate yourself, and so on. So these are interesting terminologies that are used. For example, a change of climate might make you change your mind about how best to live and turn you from a wandering nomad to a cave dweller. For example, if you're happily wandering around hunting and gathering and then an ice age sets in, you might retreat to a cave and become a cave dweller. Also, environmental stimuli such as light and sound affect the nervous system, which affects the hormonal system, which can affect the DNA RNA complexes that contribute to protein synthesis. So you are now going from environmental scale perturbations to protein scale changes in the species. Inheritance of acquired characteristics was a universal idea in Lamarck's time, and it should not be taken to exclusively characterize Lamarckism. Other people had similar ideas. Even now, a substantial number of educated members of the population of North America, including university professors, regard it as true. One way in which the idea can be taken literally is in regard to human culture. So what is discovered by an individual is passed from one person to the next and learned by a generation. Started with building tools, fishing, hunting big game, cooperation, so maybe even altruism, because is altruism passed through genes, in which case why is it evolutionarily stable? Because an altruist would suffer by sacrificing his wealth or his time, his energy to help others. Should this gene survive, if the idea of selfish gene is true? It is then passed down through the generations by education. In that sense, intellectual acquisitions become heritable. So is that epigenetic? That's the argument. For better or worse, the idea of the inheritance of acquired characteristics, largely abandoned for over a century, is now finding favor with molecular biologists. They observe that patterns of methylation, where a methyl group CH3 is added to the DNA to change the expression of a gene, for example. So that's epigenetic. It's not transmitted through genes. It's just done by temporarily changing the genetic expression. And histone binding, again similar structuring of the DNA with these histones, which are like binding agents. That repressed DNA can be imposed and changed by environmental factors, and although there is no change in the genes themselves, these patterns are inheritable. So the basic set of genes remains the same, but environment impacts certain expressions of these genes, which are then inherited. What is changed is gene expression during development, i.e. the epigenetic process. Lactose tolerance is considered one of those. So modern humans started to consume milk on a large scale with the beginning of the agriculture at the beginning of the Holocene, let's say. Over time, the gene that allows us to digest milk has expressed itself. So it's not a new gene, it's not a new evolution, it's a pattern that is inherited along the way. Okay, so there are of course environmental perturbations, but these are happening at a very slow time scale, like the continents moving from the Permian, Triassic, Jurassic, Cretaceous and present day. So ice ages have happened, land bridges have been built, migration of species has been facilitated, including humans and so on. And of course conditions for evolution have also changed by changing climate, by changing shelf areas where colonizing of land by sea creatures like algae can happen, or freshwater animals can become seawater animals, seawater species can colonize freshwater species, amphibians and so on and so forth. And the idea of emergence, for example, let's say humans can have giantism, dwarfism, pygmeism. So Happy Monster in that case says pygmies exist, dwarfs exist, giants exist, and normal humans exist, even though I want to use that word carefully. So who's the happy monster here? So the gene for giantism, dwarfism and pygmeism survive. So that's kind of the idea of happy monster and emergence of characteristics. Okay, so it could include everything: skin color, hair color, body sizes, adaptation to climate. So adaptation and adaptability, we'll visit this again, is that there is genetic adaptation to live in cold temperatures with furry skin, big bodies, fat, more fat maybe, and so on, different melanin to live in low light conditions, etc., versus adaptability, which is mastering fire to stay warm in cold climates, wearing clothes to stay warm, and so on and so forth. So adaptation, genetic, versus adaptability, which is behavioral changes, are different, and they would have occurred along the way. So what gets selected genetically versus epigenetically has to be considered as well in this story. So these are the estimated global temperatures over the last 500 million years. We will look at another different rendition of this, but you can see these are expressed as total temperatures, with the line here demarcating the world without polar ice caps and world with polar ice caps. So obviously in the current climate we have Antarctic ice, and there have been very cold times before and very warm times before, like the Cretaceous hot greenhouse. Paleocene, Eocene thermal maximum was a relatively sudden change that happened around 55 million years ago, but the global warming is now much faster than that particular spike that occurred, that we have discussed elsewhere in paleoclimate. Okay, this is another way of looking at the same thing now as anomalies from the 1960 to 1990 average temperature. Obviously during the Cambrian explosion happened, temperature was much warmer than present, including the global warming that we're expecting. So Arctic ice was not there, lush green forests in the polar circle, mammoths, woolly mammoths and dinosaurs running around. Cooling happened, evolution of vascular plants, drawdown of CO2, and again warming here with Devonian Carboniferous, when a lot of the organic matter that was photosynthesized got buried and cold temperatures happened. Extinctions along the way. Here is the Paleocene, Eocene thermal maximum again. Cooling over the last 50 million years, presumably also maybe because of the evolution of mountains like the Himalayas and Andes, and increased weathering rates, establishment of monsoons, drawdown of CO2, and the ice ages in the last million years, a couple of million years, the change in East African acidification caused by the change in the pathway between the Pacific and the Indian Ocean that led to climate change here, that could have led to evolution of bipedalism. Our ancestors are mostly quadrupedal, walking on all fours. There are many advantages of being bipedal that we will look as we go along. So climate has always been part of the story. Climate modeling still looks for these things. Paleo modeling, for example, tries to reproduce the observed temperatures here, observations and models, and tries to explain species, speciations, especially migration of our ancestors out of Africa, and so on. Okay. The other thing to remember is that if you look at number of families along the way that have existed, estimated over this same period, they have generally increased. There have been 5 mass extinctions related to crashes of meteorites and asteroids, which cause sudden climate change as opposed to geologic continental tectonic changes and volcanic eruptions, flood basalts, and so on. But after each extinction, there is an explosion of species, presumably because new environmental niches open up and new species evolve to survive in those new environmental conditions. So now we are presumably in the 6th extinction, where we are inducing disappearance of many species. Will this also lead to new species? Well, that's not something that can easily be debated without making people upset, because we are watching ourselves impact other species fairly seriously. The change we are inducing is so fast that many species cannot adapt that fast. Okay, so, and of course, what happens to many of the species as we go forth, including us? Are we so resistant that we can live in much warmer temperatures and acidic seawaters? Even though temperatures were much warmer before, remember that we were not around at the time. So it's a question of how we have evolved as modern human beings when the Holocene has been basically very quiet in terms of temperature changes, and there are evidences that even a half a degree change led to disappearance of many civilizations and so on. So that has to be kept in mind in terms of how overall life as a whole responds to large perturbations in climate, and how evolution and mutations themselves are affected by these abrupt changes in climate due to meteorite strikes and so on and so forth. So it's a very broad and general introduction. Obviously, evolution is a very detailed and still debated topic, and not everything is understood, but obviously we will just leave it at this and move on to how modern humans evolved and how behavior evolved and how climate has changed over the last 130,000 years or so, where most of the modern human Homo lineage evolution happened. So we'll get there with these kind of brief introductions. Okay.